Welcome to this explainer. Driving seems so incredibly simple, doesn't it? I mean, most adults do it every single day without a second thought. Yet consider this fascinating contradiction for a moment. A young child standing on a sidewalk can recognize danger on a road in mere seconds, while teaching a multi-million-dollar computer to do that exact same thing. Well, that has taken decades and billions of dollars in research. Today, we have cars that can navigate entire cities totally by themselves, while others still get completely paralyzed by a rogue traffic cone. It's wild. We're unpacking one of the most ambitious engineering challenges in human history. Okay, let's dive into this. So, to understand why achieving full, unrestricted autonomy has proven far more difficult than the world ever expected, we first have to look inward. We have to unpack the absolute marvel that is human perception. When you're behind the wheel, you aren't just looking at the road. You're continuously running a highly advanced dynamic risk assessment. Think about it. If you see a ball roll into the street, your brain instantly anticipates that a kid might be running right behind it. But if you see a plastic grocery bag blowing across the road, you know you don't need to slam on the brakes for that. You're applying lifetimes of context, instinct, and biological intuition in literal milliseconds. Replicating that fluid, split-second understanding of the world with rigid software code, that is an extraordinarily massive mountain to climb. And this brilliantly illustrates exactly what we're trying to do. We're essentially trying to map human anatomy onto machine architecture. Where human driving relies on instinct, experience, and real-time risk assessment, AI relies on cold, hard code, raw sensor data, and programmed logic. We are literally trying to build a synthetic human driver from scratch. The car's cameras act as its eyes. Its complex neural networks act as the brain. But here's the catch. While a human brain handles ambiguity and sudden surprises effortlessly, a computer relies entirely on absolutes. An AI doesn't have gut feelings. It only has math and data. To measure our progress in bridging that massive gap, the industry uses a standardized scale, the SAE levels of autonomy. It moves from level 0 all the way up to level 5. It starts with level 0, which is exactly what it sounds like. No automation, just you and the machine. Level 1 and 2 introduce the driver assistance you see on the roads today, like standard cruise control and lane keeping. Then we hit level 3. This is where the car can drive itself under very specific conditions, but you still need to be fully awake and ready to take over at a moment's notice. Level 4 removes the human driver entirely, but only within a geofenced area, meaning an invisible, digitally fenced-in zone, like a highly mapped-out downtown district. And finally, Level 5, the Holy Grail, a vehicle with absolutely no steering wheel and no pedals that can drive anywhere on Earth a human could. Okay, so how does a Level 4 or Level 5 vehicle actually see the world to make all of that happen? The secret lies in a concept called sensor fusion. Think of sensor fusion as a highly advanced digital nervous system. Just like your biological brain continuously combines your sense of sight, sound, and inner ear balance to keep you walking straight without falling over, the car's computer weaves together completely different streams of sensory data. It continuously synthesizes all this information to create a single, perfectly accurate 3D model of its environment. This is what allows it to detect objects and execute precise motion control in just a fraction of a second. Let's break down these new senses, because they're pretty incredible. First, we have cameras, which are crucial for reading visual info, like stop signs, traffic lights, and lane colors. Then there's LiDAR. LiDAR bounces light off surrounding objects to create incredibly detailed 3D point clouds. It's essentially drawing a high-definition digital matrix of the world out of millions of invisible laser dots. Radar operates flawlessly through dense fog and heavy rain to detect the exact speed and distance of moving objects. Ultrasonic sensors handle the close proximity stuff, like squeezing into that really tight parallel parking spot. And finally, GPS paired with high-definition maps tells the car exactly where it is, down to the centimeter. It's a stunning symphony of technology. But this is where the story becomes interesting. You see, in the industry, there's a really common saying, solving the last 1% is the hardest problem in autonomous driving. It turns out getting a car to drive straight on a sunny, well-marked highway is actually relatively easy. That's the 99%. We mastered that part a while ago. But the real world doesn't always happen on sunny, well-marked highways, does it? That remaining 1% is where the dream of full, unrestricted autonomy constantly hits a brick wall. That 1% is made up of the most unpredictable, chaotic variables imaginable: erratic human behavior, sudden, severe weather, complex ethical dilemmas, and entirely bizarre, once-in-a-lifetime events. Engineers call these chaotic variables edge cases. In a predictable environment, like a clear highway, the AI is incredibly confident. But what happens when an edge case strikes? What happens when a flatbed truck directly in front of the car suddenly drops a couch right onto the highway? Or what if someone in a full chicken suit decides to cross the road on a pogo stick? I mean, as humans, we've never seen a chicken on a pogo stick before, but our brains instantly understand that we need to stop. An AI, however, relies entirely on its training data. It is nearly impossible to train an algorithm for something that has literally never happened before. For an AI, an unprogrammed edge case can cause complete systemic confusion. So what does this all mean? With edge cases causing so much chaos, you really have to ask, why keep pushing? If teaching a car to navigate this chaotic 1% is so frustratingly difficult, why are we collectively spending billions upon billions of dollars to solve it? Why not just keep driving ourselves? Well, to understand the deep motivation behind this monumental effort, we have to look past the technological hurdles and focus on two massive drivers: the immense societal payoff and the mind-boggling financial incentives waiting right at the finish line. The first major driver is absolutely without a doubt safety. When you look at global road accidents, the vast, overwhelming majority share a single tragic root cause: human error. We get distracted, we get dangerously tired, we stare at our phones, we drive impaired. The absolute primary motivation for autonomous driving is entirely removing that massive slice of danger. Replacing fallible, distracted human error with a calculated 360-degree sensing machine that never blinks and never gets tired has the potential to save millions of lives globally. It's quite literally one of the greatest public health initiatives in history, just disguised as a technology race. Now, what's really interesting about this slide is the sheer scale of the financial race. We're looking at a $1 trillion sprint. Massive, unprecedented investments are pouring into autonomous taxi services, semiconductor companies, and highly specialized AI research. It isn't just traditional car companies anymore, folks. Tech giants, aggressive startups, and silicon manufacturers are entirely locked in one of the largest technological competitions of the century. Whoever cracks this code first doesn't just win a single market segment. They effectively build the foundational operating system for the entire future of global mobility. And the markets at stake here are staggering. We aren't just talking about selling you a personal self-driving sedan for your morning commute. We're talking about automating the entire logistics and trucking industry. Imagine a global supply chain that never has to sleep, pulling over only to refuel or recharge, moving freight across continents with brutal efficiency. We're talking about the total transformation of urban transport through ride-hailing robotaxis. This single shift creates a massive ripple effect, driving an insatiable demand for advanced semiconductors and entirely new AI infrastructure. Automating movement completely transforms the global economy. It's a real game changer. To capture these massive markets, companies are relying on a fascinating mechanism called fleet learning. Unlike human drivers who learn individually over decades of practice, autonomous vehicles share a digital hive mind. If one single robotaxi in San Francisco encounters a bizarrely parked delivery truck and learns how to safely navigate around it, that data is instantly processed and uploaded. Suddenly, an entirely different car driving in Austin, Texas, inherits that exact knowledge. Millions upon millions of miles are compounding daily. Every single mile driven autonomously teaches the entire network, constantly refining the AI's object detection and path planning at a pace humans could never, ever match. However, almost nobody knows this part. The biggest roadblocks keeping self-driving cars out of your driveway right now aren't actually technological anymore. They're systemic: cybersecurity, public trust, and liability. As the software and the sensors get better and better, the regulatory and social nightmares are just beginning to surface. We're moving away from purely engineering problems and directly into deep, systemic societal questions that require an entirely new framework of laws and ethics before this technology can truly go mainstream. We are facing a massive societal balancing act here. On one hand, the opportunities are nothing short of incredible. Unprecedented accessibility for the elderly and disabled, highly optimized traffic efficiency that could practically end gridlock, and of course, massive safety improvements. But the criticisms are equally valid. What happens to the millions of hardworking people employed in trucking, delivery, and transport? How do we protect a fully connected, digitized transportation grid from catastrophic hacking risks? And perhaps the most difficult question of all, when a Level 5, fully autonomous car without a steering wheel gets into a crash, who exactly is legally and financially responsible? Is it the passenger reading a book in the backseat? The software developer? The automaker? The entire insurance industry is scrambling to figure this out. With all of these intensely competing forces, the brilliant, world-changing technology, the trillion-dollar financial incentives, and the deeply complex societal roadblocks,
The question everyone wants answered is simply, so when will the driverless future actually arrive? Well, the reality is that it won't be a sudden overnight revolution where we all wake up tomorrow and just throw away our car keys. It's going to be a highly staged, gradual rollout that integrates into our daily lives step by step, city by city, over decades.
If we project current industry trends forward, the roadmap looks something like this. By 2030, we expect to see a massive expansion of robotaxi fleets operating in most major urban centers around the world. Fast forward to 2040, and that shift scales up tremendously with the widespread adoption of driverless trucking on major interstates, working perfectly alongside the integration of smart cities. And looking way out to 2050, we anticipate fully connected transportation ecosystems, where the vehicles, the stoplights, and the city infrastructure are all constantly communicating in real time, functioning together as one synchronized, highly efficient organism. When we finally reach that point, we're looking at a fundamentally redefined ecosystem. Imagine AI traffic management eliminating rush hour gridlock entirely, saving literally millions of hours of human life every year. Think about electric autonomous fleets deploying out to rural areas, providing reliable transit where public transport currently doesn't even exist. Consider the profound emotional independence this brings to an elderly person or someone who is visually impaired, who can simply summon a vehicle to go anywhere, anytime, without relying on anyone else. This connected infrastructure is going to change the very layout, design, and function of our modern cities. So the crucial point is this: the actual engineering of making a car drive itself has largely been solved. The sensors work, the neural networks are brilliant. The real challenge? Building a machine that can safely and consistently navigate a messy, chaotic world that was created by and is currently filled with highly unpredictable humans. We aren't just passengers in this transition. Our unpredictability is the ultimate variable in the equation. For more than a century, getting behind the wheel and driving has been one of humanity's defining, most visceral freedoms. The open road has always meant true independence. The autonomous revolution may very well redefine that freedom, not by taking the journey away from us, but by fundamentally changing what we are able to do while the journey continues. The technology is here, the massive capital is deployed, and the world is undeniably changing. So the only question left is, are we truly ready to let go of the wheel? Thanks for joining me on this explainer. Keep questioning the world around you, and I'll see you next time.
Thanks for watching World Decoded. Make sure to like and share, subscribe, and stay curious.